Hi everyone. I hope you can hear me. Let me know if everything is fine. Audio, video, everything is fine. Okay, great. So let's get started. Now we are going to continue with our discussion that we have just started, which means the linear independent and dependent set and what is the relation between ax equal to b and this thing that we are talking about, right? So let me know if there is any doubt till this point. Before that, I would really like to thank. It's not a great thing, but still, some people have really, commented out in the first video. So I really want to thank all of them. So Harish and we have got 3 4 comments till now, because the streaming just have been finished just now. But anyway, these people really deserve our appreciation because they are helping us, supporting us. So really want to thank Harish, Mr. Singh, and Amlan, right? So thank you, all of you. And if you are really liking the sessions, then please just put a comment. It really encourages us to take more marathons to put more videos like that, right? Okay. So let's get started. Now we were talking about the connection between these two. So I just left with one question that suppose we have three vectors in R2. Are these vectors linearly independent, or can these vectors could be linearly independent? So this was the question that I wanted to ask, right? Okay. Rahil is saying video not showing. I think everything is fine from my end. Everything seems to be fine, but still, if there is some problem, then let me know. Okay. Okay. Cool. So let's get started. Now I ask you this: that can these three vectors could be linearly independent? So I was telling that if you have two vectors which are linearly independent in R2, then you can fill the space, right? So similarly, like I will go for R3, R4, but before that, let's just deal with the R2. Now suppose that in R2, if I have two linearly independent vectors, right? So suppose this is R2 and I have two linearly independent vectors, any two. Suppose these two vectors are linearly independent. They has to be linearly independent because they are in the different directions, right? If this is one is not multiple of another, then obviously they are linearly independent. Now what I'm asking you that can you represent any third vector? Okay, let's suppose this vector or any vector of your choice. Can you represent this vector as a linear combination of these two vectors? Then answer is yes, right? So we can definitely suppose this is u, is this is v, represent any vector, any vector as a linear combination of u and v, because u and v are linearly independent. So these two vectors are linearly independent. That's why I can represent any vector as a linear combination of these two vectors. Now I talked about 0 1 and 1 0. These two vectors are just convenient vectors for me. That's all, right? Okay. So there is any issue with the audio video? I think everything is fine. Okay. Rahil is saying previous session. Okay, got it. So if I talk about 0 1 and 1 0, these two vectors are just as a human. These are convenient vectors for me. Otherwise, like I can take any set of two linearly independent vectors, and then I can say that any vector which I have, I can represent that vector as a linear combination of other vectors. Although I have not given you the proof, I have not given you any proof till now that why that is the case, but we will do it little later. Okay, once we deal with the rank and all, we will do it little later. But for now, just take my words. Okay, just take my words, which are this. For now for now take my words, which are this, that you can represent any vector v can be represented as a linear combination of two vectors, two linearly independent vectors, right? In R2, basically I'm talking about in R2. So in other words I can say, I have not given you the proof, but just take my words. So in other words, I will give you the proof later. Okay, in other words, that two linearly independent vectors can fill R2, can fill R2. This is just one thing that I'm telling you for now, but just take my words. We will give the proof later. Okay. Yes, a PDF will be available. Don't worry. Now if I'm asking you, can this set be linearly independent, then you will say that suppose this set is linearly independent. Okay, I just want to prove that this set is not linearly independent. Let me show how. Let me tell you how. See, suppose this set is linearly independent, then what will I say? That this and this is also linearly independent. I mean, every two is also linearly independent, because if let's suppose this is linearly dependent, then how can the complete set be linearly independent, right? So if this is linearly independent, this particular subset is linearly independent. That has to be right. I mean, the whole superset is linearly independent. That's my assumption. Then subset is also linearly independent. If that is linearly dependent, then the superset is also linearly independent, right? I hope you're getting. So basically, if I'm assuming that this whole thing is linearly independent, then this particular thing is also linearly independent. And since these two vectors in R2 are linearly independent, they must be filling the space. It means any vector you give me that can be represented as a linear combination of these two vectors. So this 4, 5, if I'm saying 4, 5, then this 4, 5 must be dependent on these two vectors. So that's why these three vectors are not linearly independent, right? So what I'm saying here is that you take any three vectors of your choice, 1, 9, okay, 3, 3, 2, 0, 5, any three vectors of your choice. And I want to just give you the intuition that these three vectors, any three vectors in in R2, any three vectors in R2 cannot be linearly independent. Cannot be linearly independent. Currently, I'm just giving you the intuition. Later, I will prove it using the rank and all. Okay. Later, using the rank, it is actually very easy to prove. You just find the rank, and rank of this matrix will be just 2, right? If the rank of this matrix is just 2, then how can these three will be linearly independent, right? So I think you know all of this, right? If you just find out the rank, then it cannot be more than 2, because there are just 2 rows. Since there are just 2 rows, the rank will be just less than or equal to 2. That's why this 3, since rank is not 3, that's why these 3 columns cannot be linearly independent. Like, that's very easy to prove using the rank. But for now, let's not go to the rank. Let's just see if I can do it using some intuition or not. So what I'm saying here is that if these 3 are linearly independent, for suppose for now these 3 are linearly independent, then these 2 must be linearly independent. Then it must mean that this must be filling the space, because any 2 linearly independent vectors in R to fill the space, right? Must be filling the space. And hence they must be producing this. So any vector can be produced by some set of vector which are actually filling the space. So they must be producing this. So that's what I mean, right? So what I'm saying here is that they must be filling the space, and since they're filling the space, they must be producing this. That's why these three vectors cannot be linearly independent. So simply putting, don't worry about the proof or intuition. You have not got it. Okay, for now, just take my words. If you have not understood anything, just take my words that any two linearly independent vectors in R2 can fill the space. Can fill the space. This is one thing. Another thing is that now if you have more than 2, if you have, okay, let me write it on another page, because this is another sentence, so I'm writing it on another page. If we have more than two vectors in R2, then they must be linearly dependent. In R2, you cannot have more than 2 linearly independent, right? In R2, similarly in R3, you cannot have more than 3. So let me just go to the R3. So now, okay, can we have more than 3 linearly independent vectors in R3? The answer is no. Okay, answer is no. So basically, why the answer is no? Don't worry about it for now. I mean, if you want, if you can relate with the rank, then you can relate with the rank. See, this is R3, right? This vector is in R3. This vector in R3. Let's put the 4 vectors. Can you have 4 linearly independent vectors in R3? No, because the rank can be at most 3, right? So that's why you cannot have. But let's not worry about the rank and all for now. So just for now, just take my words that yeah, you cannot have more than 3 linearly independent vectors in R3. Okay. Sorry, the video was huge. So I think now it is visible. Let me know if that is clear to everyone. So in R3 you cannot have more than 3. Similarly in R2 you cannot have more than 2. Right? Now in R3, if you have 3 linearly independent vectors, they will fill the space. For example, if you have this vector, if you have another vector which is this vector 0 1 0 1 0, if you have another vector which is this vector 0 0 1, if you have these three, Now give me any 4 vector. Okay, give me any fourth vector. Maybe 5, 7, 9. If you give me 5, 7, 9, I will say that okay, 5, 7, 9 is a linear combination of these three vectors. 5, 7, 9 is a linear combination of 1, 0, 0, 0, 1, 0, and 0, 0, 1. How? It is basically 5 into this plus 7 into this plus 9 into this. So basically I will say that any vector that you have is a linear combination of these three vectors. And these three are not just special vectors. I mean, they are just convenient, but there is nothing special to this. I will say that that any vector is a linear combination of any three linearly independent vectors. These three are linearly independent vectors. Why? Because no one is a multiple of another. I mean, see here, you have one here, right? You have one here, and you have zeros in the corresponding index, which means you cannot produce. You cannot produce from this zero. You cannot produce one. From this zero, you cannot produce one. So that's why like these three are linearly independent vectors. Now, how to check? That I will tell you using the rank, because that's the only way. But for now, understand that these three are linearly independent and these are just a convenient vector for us. Since they are just convenient vector for us, that's why I will say that these three vectors, I mean, are just convenient to me. That's why I will say that I can find out the coefficient very easily, which is 5, 7, and 9. But not just these three vectors. You can have any three linearly independent vectors. Let's suppose this is 2, 3, 5. Let's suppose, okay, for example, I'm just saying it. Let's suppose these two vectors 1, 2, and 4. I don't know if they are linearly independent or not, but I'm just assuming that for now these are linearly independent. Okay, so let's suppose these three are linearly independent vector. Now suppose these three are linearly independent vector. Now you give me any fourth vector. You give me any fourth vector. They actually fill the space. They actually fill the space. Fill the space. You give me any fourth vector, that fourth vector will be a linear combination of this vector. You give me, let's suppose you give me anything, 5, 7, 9. Is 5, 7, 9 is a linear combination of these three vectors? The answer is yes, definitely. How to find out the coefficients? That you need to solve the equation basically. Okay. So this is C1, 2, 3, 5. You need to actually solve the equation for C1, C2, C3, but the answer will definitely be there. If these three are linearly independent, then there could be any four vector that will be linearly dependent on this, because these three are filling the space. So any three linearly independent vectors in R3 fill the space. What do I mean by filling the space? That you give me any fourth vector, they can produce that fourth vector, which means if this is, let's suppose, R3, then you give me any fourth vector. Okay, I mean, they are actually filling the space. You give me any vector here, then I can produce that vector using my three vectors. Okay, so what do I mean? What do I mean by filling the space? It is basically that any fourth vector is a linear combination of my three vectors. So if you give me any three linearly independent vectors, okay, let's suppose these are the three linearly independent vectors that you are giving to me. One most convenient vectors that I know, but let's suppose you are giving me some other linearly three independent vectors. Then also I can actually find out that what is the like how to find out then also I can claim that this particular vector is a linear combination of these three vectors. But if you give me the convenient vector, then I will immediately tell you the coefficients also. If you do not give me three linearly independent convenient also, okay, you do not need to give me the convenient vectors. You just need to give me the independent vectors. As long as you give me three linearly independent vectors, you give me the fourth one, anyone. I will show that this one is dependent on these three. Okay. So basically, any three linear independent vectors fill the space. And if you have more than three, then there will be definitely some dependency, which means if we have more than three vectors in R3, 1, 2, 3, let's suppose four vectors in R3, then this set must be linearly dependent. Must be linearly dependent, because more than three, see, in R2 more than two are linearly dependent, and R3 more than three are linearly dependent. Okay, so in R2 more than two are linearly dependent, in R3 more than three are linearly dependent. Let me know if that is clear to everyone. So basically, to just summarize, that you can say in R2 any set with more than three is linearly dependent. Similarly, in R3 any set with three, this is more than two, with more than three vectors it is linearly independent. Sorry, linearly dependent. So either you have this, both are fine. Similarly, for Rn, you can say if you have more than n vectors, then they must be linearly dependent. Or you have two linearly independent vectors, they will fill the space. And then I will say that this set, which is 1 0 and 0 1, this is just a most convenient set. Okay, most convenient linearly independent set to me. They fill the space. Okay. Now let's do some of the question, and then probably you will be understanding more. Okay, I was here, I think. If we have more than three vectors in R3, okay, can we have more than three vectors in R3 which are linearly independent? Suppose if you give me fourth vector in R3, if you give me fourth vector, maybe anything, 5, 4, 5, 6, any vector, then this fourth vector must be linearly dependent on these three. What are the coefficient? 4, 5, and 6, right? 4 into first vector, 5 into second vector, 5 into the second vector, and then 6 into the third vector will give you this 4, 5, 6, right? Now, this set is just a convenient set to me, but if there is any linearly independent set, okay, then also it can do the same job. Cool. Are these vectors, like, are there other vectors than this? Are there other sets than this? Then yes, any three linearly independent vectors will fill the space, right? Will fill the space of R3. Let me know if that is fine to everyone. I mean, I'm not giving you any proof for now, but I'm just giving you one statement, which is that you take any three vectors in R3 which are linearly independent, you can fill your space. Okay. Now, suppose I give you these four vectors. Tell me, are they linearly independent or they are linearly dependent? Let me know. Let me know quickly if they are linearly dependent or linearly independent. So see, in R3 you cannot have more than three, right? Whatever you do, you cannot have more than three vectors which are linearly independent. So if you have this, then must be linearly independent. Must be linearly independent, right? You cannot have more than three. That's the thing for R3. So Indranil is asking, since dimension of R3 is 3, any basis? Okay, basis and all I don't want to talk about, to be honest. But if you ask the question, I can answer just this question. But for now, I will not talk about these things. Okay. So since the dimension of 3, any basis have 3 linearly independent vectors in it. Okay. And the basis is the smallest spanning set. So we cannot. Okay, you're just portraying the definition. That's cool. Okay. So you're just rewriting the definition. Now let me know if you have understood this. Okay, so they must be linearly dependent. That's what I'm saying. Now you will say that how and why. That I will tell you using the rank. See, if you put that all the vectors in the matrix, then the rank of this matrix cannot be more than 3, right? It is less than equal to 3. Then how can there will be four columns which are linearly independent? So that's why they have to be linearly dependent. I'm talking about the columns because that's what is asked. These are the columns in the matrix, right? Once you put them in the matrix as a column, then these are the columns in the matrix. Anyway, like I will talk about it more when I talk about the rank. But for now, I need it to solve some of the questions. That's why I'm just telling you upfront. Okay. Similarly, can we have more than n independent vectors in Rn? Then answer is no. Okay. So for example, let's suppose determine if the following vectors, they are saying linearly independent or not. Then you will say that these vectors are in R3 and these are the four vectors. Then the answer is there are four vectors in R3. See, the question I have taken from the Washington University and from their maths department. Then what they are saying, these are the four vectors in R3, so they cannot be linearly independent. Why their theorem or whatever, like, I mean, text they have used. So it does not matter to us. But yeah, I hope you understood this, right? Okay. Now let's just move further. Now tell me if it is true or false. What they are saying, any set of m is greater than n. Let's just take m is 3 and n is 2. Okay, and in R2 is necessarily in R2 any set of 3 is necessarily linearly dependent. Tell me if it is true or false. The first statement is true or false. And the second statement, any set m is less than or equal to n. Let's suppose this time let's take it to 3, this time let's take it 2, which means R3. Any set of two vectors in R3 could be linearly independent. Just tell me which one is true, which one is false. Let me know. Okay, first is true. They are saying, people are saying first is true, that any set of three vectors in R2 necessarily linearly dependent. Yes, that is true. Yeah. Second is saying any set of two vectors in R3 could be linearly independent. Yeah, they could be, right? I mean, you take 1, 2, 3, this is one vector in R3. You take 2, 4, and instead of 6, take 7. Okay, 2, 4, 7. Yeah, these are the two vectors which could be, I mean, which are actually linearly independent. So that's why this is also true, right? So why 2 is false? They are saying you take any two vectors in R3, any set in R3 could be linearly independent. Yeah, they could be. They could be linearly dependent. They could be linearly independent, right? Could be dependent also. For example, this 1, 2, 3, and if I take 2, 4, 6, then they are linearly dependent. You have taken 2, they are linearly dependent. You have taken these two, are linearly dependent. They could be anything, right? It depends on the vectors that you are taking. So both are true, right? See here, both are true. This is true, this is true. Okay. Now, this is end of linearly dependent and independent vectors. Now we are going to see the next topic, which is Ax equal to b, right? Ax equal to how to multiply a matrix and a vector, and then we will relate both of this. So till now we have just seen few intuitions that what is linearly independent and independent. Don't worry, let me just tell you this topic, which is Ax equal to b, and then before I relate both of them, before that, I will just summarize all of this in just a quick 3 to 4 slides. I have 3 to 4 summary slides also. Okay. So first let me cover this, and then I will just summarize whatever we have studied from the session 1. Okay. From the session 1 itself, I will summarize everything in just 4 to 5 slides, because to be honest, till now we have not studied anything much. If you want, you can just summarize in 1 or 2 lines. Till now we have what we have studied: linear dependent, independent. You can just write the definition using this C1, C2, C whatever, right? And filling the space only. These are the two things that we have studied till now. Anyway, I will be summarizing it. Don't worry. So this is end of this topic. Now next, multiplying a matrix with a vector. So let me know if you're ready, because this is going to be most interesting topic. Okay. So Rohit, complete engineering mathematics most probably we will be doing. Okay, I cannot 100% say, but yeah, if we in this marathon, what we are trying to do, if we are starting something, we are just going to finish it so that you do not left behind in between. So we will do most probably the complete engineering mathematics, which means the linear algebra and probability that is required for GATE. Okay. So what is a matrix? Matrix is just a you can say you have put the set of vectors in set of vectors here, and this is called a matrix, right? So a couple of vectors put together is basically forming a matrix like that. Now let's see the most interesting topic, which is matrix into vector. How to multiply a matrix and a vector. So suppose if I just ask you to multiply this matrix and this vector, then what you will do? Maybe you can multiply easily. How? You will say that let me multiply, this is a matrix, this is a vector, let me multiply this particular row with this particular column, and let me get the answer. So if you multiply this particular row with this particular column, then what is your what is the number that you will be getting here? I think you will be getting 2, right? This is 2 into 4, 2 into 1 plus 4 into 0, 2. And then you will be getting 3 into 1 plus 5 into 0, right? You will be multiplying this and this, then you will be getting 3. So isn't it? You will be getting 2, 3. That's how you multiply matrix and a vector. So I hope that is clear to everyone. Rahil is asking, please explain what is R1. R1 is just a scalar. Okay. R1 is just a scalar. Now, please just focus here, because this is going to be a very interesting topic. Okay. Have you understood this? The how to multiply a matrix and vector. Then obviously we are not interested in this kind of multiplication. Otherwise, I would not have created that much hype. This particular way of multiplication is basically the connection between Ax equal to b and the linearly dependent and independent whatever we have studied. Okay. So let's see a very interesting, very amazing way to multiply a matrix and a vector. Let's see. So this is the answer that you got. But let me just tell you another way. How? What will I do? I will take this vector, whatever the vector it is. I will take this vector, which is 2, 3, and I will write this vector here. I will take another vector which is 4, 5. I will write this vector here. And I will basically say that if you want to multiply this matrix and this vector, then what you do, take the coefficients, which means this is 1. I mean, as a coefficient, this is 1 plus this is 0, and then you get your answer. What is the, if you do it, then 1 times this is 2, 3, and then plus 0, then you will be getting 2, 3. Isn't it? Aren't you getting the same answer that you have just got? So using that multiplication, you have got the same answer. Using this multiplication also, you have got the same answer. So earlier also you have got the same answer, which means if you are multiplying this row with this column and this row with this column, and then you will get into 3. Now I'm just going to discover another way, which is saying you just write this vector as it is. You just write this vector as it is. Take the linear combination of these two vectors. And how you will be getting the coefficient for the linear combination? Coefficients will be this. Then this right hand side vector is just a linear combination of these two vectors. Let me give you more examples. So suppose that you want to multiply these two matrices. This matrix and this vector. Suppose you want to multiply this matrix and this vector. Then what you will do? You will say that, okay, let's just do one thing. I mean, one quick way, or one, not the quick, I will say one of the most convenient way for you till now is basically just to multiply this row and this column, and then you get this 18, and then you multiply this row and this column, you got this 6. But instead of doing this, what I'm saying, you write this vector which is 4, 6. You write this vector here. You write another vector 7, 0. Take the linear combination of these two vectors to get your answer. How to take the linear combination? Just write the coefficients from this vector, which is 1 and 2. If you do so, then this is 4 plus 17, 4 plus 14, which is 18, and then this is 6 plus 0, which is 6. Very easy, right? You can easily find out using the linear combination. Let me know if that is clear to everyone. Okay, maybe I can take more questions, right? So let's take anything. Let's suppose if I'm picking this is 1, 2, 3, this is 5, 6, 7, this is 9, 10, 11, anything, okay? And then let's suppose I'm saying this is 1, 0, 1, or anything. I mean, you can take any vector. Let's suppose I want to multiply these two vectors. You do your way, I will be doing my way, which means you multiply this row with this column. You get your answer. Let me just tell you that how you get answer in another way. What you need to do, you need to just put all of the vectors here, and you need to take the linear combination of these all vectors, which means this will be 5, 6, 7. Okay, and then this is basically 9, 10, 11. You take the linear combination, then you ask me how you will be getting the coefficient. Coefficients will be from here 1, 0, and then 1, right? And then 1. Then you will say this is 0, so let me just not count it. 1 plus 9 is 10. 2 plus 10 is 12. 3 plus 11 is 14. So basically 10, 12, 14 must be the answer. You can use your own way. Yeah, so Subhadeep is saying he has learned this technique using one of my Go answer. Yeah, at one place in the Go, I have answered using this technique so that other people also get to know if they are not watching the lecture. So you can do your own way. You will be getting the same answer. Isn't it so amazing? Now you will say why it is amazing. I mean, anyway, I am getting the answer either in that way or in that way. But it is extremely amazing. So whatever question they are going to ask in your interview, or whatever question you need to deal with using ax equal to b, all of this falls upon just this single method of multiplying a matrix and a vector. How? See here. In earlier method, whatever you used to do, are you bringing any intuition? So you are multiplying this and this. You are not bringing any intuition there, right? But here you are saying that on the right hand side, it is basically a linear combination of these three vectors, right? So you can say that right hand side, whatever right hand side you are going to get is always a linear combination of these three vectors, isn't it? And how you will be getting the coefficient? Coefficient will be from here. So isn't it right to say that if you are writing ax equal to b, okay, this is the first time I'm writing ax equal to b. So isn't it right to say that let's suppose A is a matrix which is having some column vectors, and then whatever your x is, so whatever b you are going to get, this b, okay, this is A, and there will be obviously x, this is b, whatever b you are going to get, it is a linear combination of these three vectors, isn't it? Isn't B a linear combination of these three vectors? Tell me. How you will be getting coefficients? Coefficients will be from here, right? So this B is always this is very extremely important to understand, because this will just summarize, or this will just connect all the dots. Whatever we are going to see in Ax equal to B, like it is necessary to understand this, otherwise you will not be able to understand Ax equal to B. So B is linear combination of columns of A. Let me know if that is fine to everyone. Yes, I have answered that question. Mr. Singh is saying that eigenvector question. Yes, I have answered that question using this method. So anyway, but that question is basically not have to be done using this method. This method is mostly for the Ax equal to B. I mean, to understand what is this Ax doing. But just to show that yes, this method exists, I have actually answered that question using this method. Let me know if there is any problem in this method. So let me just put that answer that I have answered on the GATEOverflow, because many of the people have talked about that. So see here, this is one of the answer that people are talking. Let me probably that put the answer here. So here also, I have answered one of the question on GATEOverflow. That is just recent question, GATE 2022 question. Here also, like I have answered in such a way that this whatever we are getting, if you just see, if you just zoom this out. So here whatever we are getting is basically a linear combination of these vectors. See, this vector I'm putting here, this vector I'm putting here, this vector here, and the coefficients will be from your this x, isn't it? So this is very, very important to understand this method, because this method will drive you the connection between whatever we have studied and what is the what is this Ax equal to B. Let me know if there is any issue in understanding this method. Okay, so let's just continue, right? Now this Ax equal to B, I can say that B is a linear combination of columns of A. So if I'm saying that this is 1, it means I'm picking the first vector, picking the second vector, and I'm just adding them, right? So let's suppose someone asks you the reverse question. Let me just ask you the reverse question, which means let's suppose this is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And let's suppose someone asks you a reverse question, that they ask you the x such that you get 4, 5, 6. What you will say? Which means you need to pick the middle vector. Which means what should be the coefficient? Let me know very quickly. What should be your coefficient if you want to pick the middle vector? If you want to pick the middle vector, then your coefficient should be 0, 1, 0, isn't it? Very easy to find out the coefficients. Now, suppose for the same question, they say that the vector that you are getting at the end is 7, 8, 9. Okay, this is 7, this is 8, this is 9. What should be this vector then? What should I be writing here? Let me know. Okay, in this case, I will be writing 0, 0, 1, right? Cool. Suppose someone says, now I'm going to make it a little tricky. Suppose someone says that this is going to be, the vector that you are getting is going to be 5, 7, and 9. Then let me know what is the numbers that you should be writing. If it is going to be 5, 7, 9, then what is the numbers that you should be writing? Let me know. See here, this 5, 7, 9 is basically I have written in such a way that it is a linear combination of these two, which means this one and this one, which means you will be writing, you need to take this, you need to take this, you need to add both of this, and then this 0. Then this is 1 plus 4, 5, 7, and 9, right? Okay. Let me make it more interesting. Suppose instead of this, just if I just say that if you need to have, let's suppose 6, 9, 12, then what you should be writing here? I mean, just guess it. I mean, obviously there should be some way to solve, but just guess it. I'm just saying to guess. Okay, just guess it, that what should you should be writing here, just like a puzzle. So see here, you need to pick 2 times of this, and then 1 times of this, and 0 times of this, which means This is 2 times of this. If you multiply 2 plus 4 is 6, basically 4 plus 5 is 9, and 6 plus 6 is 12. So if you need to pick 2 times of this, 1 times of this, and 0 times of this, then you will be writing 210, right? So yes, that is right. So Yash, Subhadeep, and Akash have given the correct answer. So actually, what I want to convey is that whatever you have at the right hand side, this right hand side is always a linear combination of of the column vectors of A. So if you write A, if you write X, and then whatever you are getting here, right? If this is A, this is X, this is B. This B is always linear combination of columns. So this is what is very important to understand. Okay, let's just move further. Now, suppose if I ask whether it is true or false, I give you A, I give you X. These are the columns of A. Okay, these are the columns of A. Suppose I give you A, I give you X, and I give you B, and I mean I calculate the B. So if I say that B is a linear combination of columns of A, then let me know if this is true or false. This is true, right? Because B is always a linear combination of columns of A. So that's why I can say this. Now let's move to more interesting questions, and let's actually move to Ax equal to 0 or Ax equal to B. So suppose if I say if Ax equal to 0 has some non-trivial solution, then columns of A are linearly dependent. Take your time and answer this question. This is going to be very first question which is relating actually X equal to 0 and linearly independent or dependent, right? So whatever we have studied as a linearly dependent, independent, right? And then X equal to 0, these two things we are first time going to relate. I know that most of you might not be able to get this answer correctly, but that is fine. I mean, I'm just putting it as answer, although I have just first taught, I should have taught you, then I should put it as answer, but let me just directly put it as a question. Let me know what do you think. It is true or false? Okay. So most of you are getting true. Let's see if it is true. If Ax equal to 0 has some non-trivial solution, what does this mean? Let's just first understand what is Ax equal to 0. Ax equal to 0 is basically, this is A, this is X, and then this is 0, right? Equal to this, everything is 0. So here, what I'm saying here is that let's suppose this vector is, let's suppose A1, small a1, this vector is small a2, this vector is small a3. Okay. These coefficients could be x1, x2, x3, or c1, c2, c3, anything. Let's suppose this is A, this is X, this is 0. Let me know if the writing is fine to everyone. I mean, the notations are fine. A1 is not a scalar. A1 is a vector. That's why I'm just writing it like that. I mean, just writing the arrows. This is a vector, this is a vector, this is a vector, these three are scalars, right? The notations are fine to everyone. Now, the way we have just multiplied, can you say that the C1, A1, because you need to take A1, A2, A3 linear combination, and the coefficients will be coming from here. Can I say C1, A1 plus C2, A2 plus C3, A3 is equal to this vector 0? Or maybe let me just go to the next page. Here, what I'm saying is basically this C1 into A1, because that's the way we multiply, right? C3 into A3 is equal to 0, 0, 0, right? Is this okay to everyone? By writing this matrix notation using this linear combination notations, and that's how actually both of things are related. This is just a matrix notation. This is notation of linear combination, right? And that's where the both of the things are relating to each other. Now, if I say that Ax equal to 0 has has some non-trivial solution. If I'm saying some non-trivial, matlab, I'm saying that there is some non-zero that also satisfy, right? There is some non-zero Ci which also satisfy, which means that there is some non-zero satisfy. See, if this kind of equation is given to me, then I always ask a question: do you have some non-zero satisfy? Non-zero Ci. Do you have some non-zero Ci? That's the question that I always ask, right? Some non-zero and it is given in the question that yes, they have the non-zero ci, right? It is given in the question. They are saying that there exists a non-trivial solution for x equal to 0. X is what? X is just c1 c2 c3, right? There exists some non-trivial, which means that ci is non-zero. Then they will give me the ci. If they give me the ci, I can represent one of the vector as a linear combination of other vectors. It means that a1 a2 a3 are linearly dependent. Let me know if you have understood this particular question or not. Yes, Jigar. So Jigar Patel is saying that means we have Ci which is not equal to 0. Yes, that's very nice observation. Right? Everyone has understood this. What they are saying? They are saying that there is some non-trivial solution. It means there is some non-zero Ci. It means first I need to represent. See, you should be extremely comfortable in writing one from another. Either they give you the matter notation, maybe you need to convert to this. They maybe giving you this, and then maybe you need to convert to this. Okay, so you should be extremely comfortable. I mean, there should not be any differentiation to you if you are writing either matrix Ax equal to 0 or you are writing as a linear combination of columns of A. Okay. So that's where these dots are getting connected. That Ax equal to 0 is nothing but a linear combination of columns of A. Right? Ax is nothing but a linear combination of columns of A. If you write Ax, you can say this is nothing. This is same as linear combination of columns of A. So I hope this question is clear, because they are saying non-trivial solution, which means indirectly they are saying that there is a non-zero CI. Okay, I need to know कि non-zero है कि नहीं. जीरो से मुझे फर्क नहीं पड़ता, केवल मुझे जीरो के बारे में इन्फॉर्मेशन दे रहे हो, non-zero के बारे में नहीं बता रहे हो, तो I do not care. You should be telling about the non-zero. They are saying कि non-zero है. It means कि मैं कोई तो अगर जो भी non-zero है मैं उसके corresponding, अगर ये वाला non-zero है तो I can represent A1, and which means they are linearly dependent. So what they are saying, no, then columns of A are linearly dependent. Then answer is yes. That's why it is true. Okay, hope that is okay to everyone. Okay, now someone is saying, can we visualize it using a straight line in 2D? If the vectors are in R2, then only you can do it. If vectors are not in R2, then it is not easy to visualize it. You cannot visualize the things which are in I mean, whenever you go more than 3D, you cannot visualize it. Okay, can we say trivial solution? Cool. Now let's just understand it more. So Ax equal to 0 has some solution. Then can you say about the linear dependency of the columns? So suppose if I just give you this information, okay, if I just ask you this question that Ax equal to 0 has some solution, then what can you say about the linear dependency of column? Which means that I say that this equation Ax equal to 0 has some solution means immediately means that this equation, right? This equation, writing this equation and Ax equal to 0 is actually same. So if they say Ax equal to 0, you should mean that they are basically writing this equation, right? They are saying this equation is having some solution. Okay. Then what can you say about the linear dependency? Whether the columns are linearly dependent or independent. Let me know. Exactly. So Ax equal to 0 always has some solution, right? They are saying they have some solution. वो तो मुझे भी पता है ना कि some solution है. C1 equal to 0, C2 equal to 0, C2, C3 equal to 0 है तो सही solution. मतलब what they are telling me, they are not telling me anything new, right? I also know कि वो solution तो है ही. X equal to 0 का एक solution तो होता ही है, X equal to 0, right? Ax equal to 0 always have the trivial solution which is x equal to 0. They are saying they have some solution. So what? I mean, वो तो मुझे ही पता है कि वो solution है. They should tell me whether there is only trivial solution. There is some non-trivial solution like that. मतलब कुछ तो extra पता है ना. कुछ solution है वो तो पता है, सबको पता है, right? Okay. No, let me just go here. Let me just ask this question another way. Ax equal to 0 has some non-trivial solution. If they say non-trivial, ठीक है? If they say non-trivial, then this question is little making some sense. If they are saying non-trivial, it means they are saying the CI non-zero है. That means linearly independent है. तो linearly dependent है. अगर वो non-trivial बोलते हैं तो ही है. अगर वो नहीं बोल रहे हैं, then I don't know. I don't know. Okay. If they are saying नॉन ट्रिवियल, अगर वो बोल रहे हैं कि सम नॉन ट्रिवियल सॉल्यूशन है, देन इट मेक्स सम सेंस. दे आर सेइंग सम ट्रिवियल सम सॉल्यूशन, तो वो तो ट्रिवियल भी हो सकता है ना. देन इट इज नॉट वेरी गुड रीजनिंग. आई मीन वेरी गुड स्टेटमेंट बेसिकली. Okay, this is this statement basically is not bringing me any information. They are saying कुछ solution है, वो तो मुझे भी पता है कि कुछ solution है. x equal to 0 तो है ही ना solution. x equal to 0 तो कुछ solution है ही. Okay. So till now, let me just summarize everything before we go further, because now we are entering into the world of linear algebra. Okay, we are actually entering now. So we have just built the basics. We now know how to multiply a matrix, a vector. So basically, we know what is a linearly dependent and linearly independent, right? We know we cannot have more than n linearly independent vectors in Rn. I mean till now अभी तक के लिए थोड़ा ऑनेस्टली रटा ही है ये वाला स्टेटमेंट, थोड़ा बाई हार्ट ही किया है. मतलब कि R2 में 2 से ज़्यादा नहीं हो सकते, राइट. R2 में अगर आप 2 से ज़्यादा ले लोगे तो फिर रैंक ही इनकी मतलब लाइक लेस देन इक्वल टू 2 होती है. तो उतना तो थोड़ा बेसिक इंट्यूशन तो पता है, बट अभी तक के लिए थोड़ा रटा हुआ है ना. सेकंड स्टेटमेंट का मैंने कोई प्रूफ नहीं दिया है, क्योंकि अभी मैं नहीं दे सकता उसका प्रूफ. तो फर्स्ट वी नो कि लीनियरली डिपेंडेंट इंडिपेंडेंट क्या होता है. मैट्रिक्स को वेक्टर से कैसे मल्टीप्लाई करना होता है वो भी हमें पता है. एंड वी ऑल्सो नो कि R2 में या फिर Rn में मोर देन n नहीं हो सकते लीनियरली डिपेंडेंट की अगर बात करें तो, राइट. तो दिस थिंग्स वी नो. Now we are entering into the world of linear algebra with the basic information that we know. Okay, so this is just a summary. मतलब अभी तक ये बस summary, मतलब summary in the sense कि ये हमें पता है. I think ये points obvious हैं. Let me know if there is any doubt in this. Okay, linear dependent independent क्या होता है वो हमें पता है. हमें equation दी जाएगी, like they will give us some equation, and then we will ask कि वो एक CI है कि नहीं उसमें, right? At least do you have one CI or not? That whole story you know. Okay, cool. Now let's just move further. Suppose they give you this matrix, this vector, okay, and then they ask you that what you should be filling in place of x, y, z, w. Okay, let's just have an exercise. So what you will say, if I just give you a hint कि इन दोनों के summation से you are getting this thing, then what you will be answering? Let me know your answer. Yeah, it is very easy, right? It is basically you are saying 1 1, you can take this and you do not need these things. So 1 1 0 0, right? Very easy. No, I'm just asking this x, y, z, w. It is 1 1 1 1 z, w. Okay, 1 1 0 0. Now in gate only mainly two things are there: ax equal to b and eigenvalues, eigenvectors. Obviously determinant and all of this little bit things are also there. How to find determinant and all. So I hope that you know how to find the determinants, right? Mainly we will be seeing ax equal to b and eigenvalues, eigenvector. So now we are going to enter into the world of linear algebra. So remember, I have just told you that we have asked this question that how to find the linear combination of the vectors. So I think that way was very easy for us, that how to find the linear combination of the vectors. Finding the linear combination of the vectors was very easy. Now we are going to flip this question. What we are going to say, that instead of asking that how to find the linear combination of the vectors, I am just going to say that okay, the linear combination will be given to you. How to find the coefficients? That's going to be an interesting question, isn't it? That's what ax equal to b says. So this is just a, this is a, these are the just x, these are x, this is b. So you need to find this x, right? I mean, see, given this a and x, you can find definitely b. I mean, there is nothing in this, and that's what we did, right? Given this is a, this is x, you can definitely find b. There is nothing fancy in this. But now let me ask a reverse question, or let me just flip this question a little bit. Instead of giving you the right hand side b, I mean, instead of asking you right hand side b, I will be giving the right hand side b, and then I will be asking the coefficient. That's what ax equal to b says, isn't it? So I hope that is clear to everyone. Let me know if you have any doubt. Okay, so let's just get started now. Now what we are going to say, that we will be given a and then we will also be given b, and then they are going to ask us x, right? Cool. So basically they will give us that this is a equation, this is a equation, this is a equation. Now these three equations which they have represented in just a row way, okay, this is one row, second row, third row, what we are going to do, these equations we can represent Ax equal to B, and then we can represent, in turn we can represent these three equations only in the column way. So you need to represent those equations in a column way to understand in the linear algebra perspective. So what you're going to do, you are going to represent these equations in a column way also. How? You will say that this thing writing like this, or maybe writing like this, all of this is fine, which means you will say 126 into x plus y into 2 5 minus 3 plus z into 3 2 1. The handwriting is not too good. Okay, so z into 3 2 1 equal to 642, and they are asking x y z. So you need to understand one thing, that all of this is same. They will give you this, they will give you this. Okay, maybe they will give you this, they might give you this. Okay, or they give you this or they give you this. You need to understand that all of this is same as a linear combination of this. So basically you need to basically convert that to a linear combination first. Okay, let me know if you have understood this. Okay, now suppose if I just ask you, I'm just going to revise few of the things here and there, so that you do not, you actually feel more confident. So suppose if I just ask you to multiply this matrix and this vector, then you will say, okay, just don't take it in two times of this, right? Two times of this. That's how you can multiply this matrix and this vector, and then you will be getting this vector. Suppose if I ask you to multiply this matrix and this vector, it means four times this, five times this, six times this, but these vectors are zero. That's why you will be getting 4 4 4. So I'm just giving you some examples so that you are just more comfortable with the way of multiplying a matrix and the vectors. Okay, let's get started now. So suppose if I just ask you to multiply this matrix and this vector, since it is identity matrix, so maybe you can do it easily. But if I do it using the way that we have studied, so basically 4 into this, 5 into this, and 6 into this, and you will be getting this 4 5 6. Now let's solve this question. Suppose a matrix A, which is a 3 into 3 dimension, contains 3 linearly independent columns. What can you say about the number of solutions to Ax equal to B? Okay, instead of number of solutions, let me write the whether the solution exists or not. So don't worry about the number of solutions. You can say that what can you say about, instead of number of solution, let me say about the solutions basically. Whether the solution exists or not. So let's just do this question. What I'm asking here is that, suppose that the matrix A contains A, which is 3 cross 3, right? Which means 3 rows and 3 columns. See, if there are 3 rows and 3 columns, which means if there are 3 rows, which means 1 2 3, right? This means every vector number of rows will determine that every vector is in dimension R3, right? And there are such 3 vectors basically. That's what they are saying. 3 into 3, right? Very easy to see that there are 3 vectors in R3, right? Because the dimension is 3 into 3. Contains 3 linearly independent columns. Now they are saying that good thing about this matrix is that these 3 vectors are linearly independent. Then, okay. Then if you have Ax equal to B, then will you be having the solution of Ax equal to B or not? That's what they are asking. Let me know. Maybe there is some difficulty in this question, but I will just clarify this question, and then you should be able to solve other questions. But before that, I just want to give you some time to solve it. By the way, there are some merchandise from Go classes. I don't know why I'm advertising it, but yeah, this is also from Go classes. Like, I'm very excited to, to basically use those products that we have actually. Obviously we have spent some money. We have not got it as a gift, but yeah, this is also very nice to use those as a daily to daily routine. I hope that you also people get some good rank, either in gate or at least in some either in AMT1 or AMT2, and then you will also be getting those merchandise. Okay, so what is the answer that you are getting? let me just show you that how to solve these kind of questions, and there are plenty of questions then we are going to solve, right? So what they will say, they will give you the a, right? I mean, they might give you the actual numbers, or they will give you some information about the a. Suppose I give you the a, which is maybe, let's suppose I give you 1 2 3, and then this is let's suppose maybe 3 4 5, and suppose I give you b, right? I give you b, which happens to be 4 6 and 8. Now if I just ask you this x1 x2, then can you tell me? I think you can easily tell me, right? What you will say? Maybe you will say, I think 1 and 1, right? So you will say 1 and 1. Great. So you can definitely tell me, right? I hope that is fine to everyone. Okay. Now I'm going to change it a little bit, which is basically what I'm going to do. I'm going to change these numbers a little bit, and I'm again going to ask this number. Let's suppose from this 8, I just give you 9. Okay. From this 8, I say 9. So earlier it was 1 1. Sorry, it was earlier it was 4 6 8, and then I ask you, you said it is 1 1, right? If it is 4 6 8, then if I ask you, you said it is 1 1. Now instead of 4 6 8, I'm saying it is 4 6 9. Now tell me what are the numbers that you are having. See, the thing is that you cannot have numbers for everything. Now there is no solution, right? Why that is the case? See here, this thing, now understand it very very carefully, that this thing, whatever you are going to get, whether you put 1 1, you put 1 2, or whatever you put here, this thing is always a linear combination of columns of a. Okay, whatever you put here, right? This is always a linear combination. This is ax, which is always a linear combination. Always always means always a linear combination, a linear combination of columns of a, isn't it? I mean, nobody can deny this, that this is always a linear combination of columns of a. Now on the right hand side, if I put a linear combination of columns of a, then only I will get a solution. If I put a something which is not even a linear combination of columns of a, suppose मैंने 4 6 9 पुट किया, जो कि इन दोनों के लीनियर कॉम्बिनेशन से आ ही नहीं सकता, तो फिर कोफिशिएंट कैसे लिखूंगा मैं, राइट? क्योंकि सी, अगर ये जो राइट हैंड साइड है, मैंने कुछ भी आर्बिट्ररी लिख दिया जो कि लीनियर कॉम्बिनेशन से बन ही नहीं सकता, तो फिर कोफिशिएंट्स कहां से लाऊंगा? गेटिंग माय पॉइंट? So if B is a linear combination of columns of A, then only Ax equal to B has some solution. Otherwise Ax equal to B can never ever have some solution. So this line is extremely powerful, that if B is, in fact in GATE also they have 2-3 times asked this line in one way or another. I will show you the GATE PYQs now, okay? But for now, for that I need to build some basics also. So I'm saying if B is in a linear combination of columns of A, then Ax equal to B has some solution. Suppose I ask whether it is true or false. What you will say? Is this true or false? So this is true, right? This is true. I will say yes, that is true. That if B is, see, जो A है इसमें मैं x का मल्टीप्लाई करूंगा तो मुझे लीनियर कॉम्बिनेशन ही मिलेगा ना A का. अगर राइट हैंड साइड में भी लीनियर कॉम्बिनेशन है, तो अगर मान लो, अगर मैं बोलता हूं कि राइट हैंड साइड में जो आपने B लिखा वो लीनियर कॉम्बिनेशन है A के कॉलम्स का, देन आई विल जस्ट आस्क यू कि लीनियर कॉम्बिनेशन है तो मुझे कोफिशिएंट्स बता दो ना. अगर कोफिशिएंट्स बता दोगे तो मैं यहाँ लिख दूंगा, है ना, एंड आई विल गेटिंग B. So basically this Ax is always a linear combination of columns of A, right? अगर राइट हैंड साइड में लीनियर कॉम्बिनेशन ही है ना, मुझे बस कोफिशिएंट देखने वो मैं कर दूंगा. लाइक राइट हैंड साइड में भी अगर लीनियर कॉम्बिनेशन है तो कोई दिक्कत नहीं है, मुझे बस कोफिशिएंट फाइंड आउट करने हैं, है ना? मुझे ए गिवन है, बी गिवन है, मुझे बस कोफिशिएंट फाइंड आउट करने, मैं कर दूंगा। अगर मेरे को बोला गया है कि बी लीनियर कॉम्बिनेशन है, अगर बी लीनियर कॉम्बिनेशन में ही नहीं है, मे बी लेट्स सपोज ये है, जो कि कुछ भी कर लो, आ ही नहीं सकता बी, है ना? कोई भी लीनियर कॉम्बिनेशन ले आओ, क्योंकि वो लीनियर कॉम्बिनेशन का है ही नहीं। If B is not in linear combination of columns of A, then no matter what you do, you cannot find the coefficients, right? How can you find those coefficients if B is not even a linear combination of columns of A? Getting my point? So basically, if 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 B is a linear combination of columns of A, then Ax equal to B have some solution, and vice versa also. Which means if that is not in a linear combination of columns of A, if B is not in a linear combination of columns of A, then Ax equal to B has no solution whatsoever it is, right? अगर वो लीनियर कॉम्बिनेशन में ही नहीं है, अगर B वट एवर आई एम राइटिंग हेयर, अगर वो लीनियर कॉम्बिनेशन ही नहीं है, तो फिर कोई सेंस है उस बात का? मतलब अगर लीनियर कॉम्बिनेशन ही नहीं है B, तो फिर हम कोफिशिएंट्स कहाँ से लाएंगे जब वो लीनियर कॉम्बिनेशन में ही नहीं है? तो क्योंकि ये तो हमेशा लीनियर कॉम्बिनेशन देगा ना। अगर B ही लीनियर कॉम्बिनेशन में नहीं है, तो कोफिशिएंट्स ही नहीं आएंगे ना कभी। यू अंडरस्टैंड दिस? नाउ लेट्स जस्ट मूव टू दिस क्वेश्चन। व्हाट दे आर सेइंग कि ए के जो वेक्टर है ना, वो तीनों R3 में फर्स्ट ऑफ ऑल, और तीनों लीनियरली इंडिपेंडेंट है। गुड थिंग इज दिस, R3 में मेरे को 3 लीनियर इंडिपेंडेंट मिल जाए तो लाइफ ही सेट है ना। वाई? क्योंकि मैं पूरा स्पेस ही फिल कर दूंगा। मेरे को तुम कोई भी वेक्टर दे दो, है ना, कोई भी बी दे दो, इस बी को मैं ढूंढ निकालूंगा। विच मीन्स आई कैन डेफिनेटली प्रोड्यूस दिस बी। देयर मस्ट एग्जिस्ट सम कोएफिशिएंट दैट कैन गिव मी दिस बी, विच मीन्स देयर मस्ट बी सम एक्स, देयर इज ऑलवेज सम एक्स। अगर मुझे R3 में 3 लीनियर इंडिपेंडेंट मिल जाएं, मैं लाइक इट्स लाइक कि दुनिया कर लो मुट्ठी में, लाइक आई मीन देयर इज नथिंग हु कैन बीट मी। कोई भी वेक्टर दोगे मुझे, सिंस आई कैन फिल द स्पेस, आई एम द ओनर। मुझे R3, मेरे पास पूरा R3 है, मैं पूरे R3 पे राज कर रहा हूँ। I have 3 linear independent vectors in R3, which means I can fill the space. If I can fill the space, no matter what B you give me, I will give you the coefficients, right? So basically, if for this question I will say that what can you say about the solutions of x equal to b, you will say there is always a solution. Whether there is a unique solution, infinite solution, I will come to that point. Okay, so you will say there is always a solution. Let me know if that is fine to everyone, because that's very crucial thing. Okay, okay, so I hope that is fine, right? So basically, if R3, they are saying R3 is having 3 linear independent, then I will always have the solution, right? Okay, let's go to this question. What they are saying is that suppose a matrix A, which is 3 into 4, contains 3 linear independent columns. Okay, 3 into 4 means 3 rows and 4 columns. तो बेसिकली 3 रोज, राइट? तो हर एक वेक्टर R3 में है ना, और ऐसे 4 वेक्टर्स हैं। दीज आर द 4 वेक्टर्स, ये R3 में, ये हर एक R3 में। एंड देन दे आर सेइंग कंटेन्स 3 लीनियर इंडिपेंडेंट कॉलम्स। आउट ऑफ दोज 4, 3 मेरे पास, आउट ऑफ दोज 4 कॉलम्स, 3 कॉलम्स आर लीनियर इंडिपेंडेंट, एंड देयर कैन नॉट बी ऑब्वियसली मोर देन 3, क्योंकि R3 है। R3 में मोर देन 3 तो हो ही नहीं सकते थे। एनीवे, नाउ व्हाट कैन यू से अबाउट द सॉल्यूशंस टू x इक्वल टू b? आपको क्या लगता है, सॉल्यूशन होगा कि नहीं होगा? फॉर एनी बी, ओके, इट्स नॉट फॉर पर्टिकुलर बी, आई मीन फॉर एनी बी, विल देयर बी अ सॉल्यूशन? देयर इज ऑलवेज अ सॉल्यूशन। व्हाई? क्योंकि मुझे R3 में 3 लीनियर इंडिपेंडेंट है ना मेरे पास, चौथा तो फालतू ही है। चौथे का क्या करूं? आई एम द ओनर, आई कैन प्रोड्यूस दिस फोर्थ वन, राइट? In an R3, I have 3 linear independent columns. I can produce any B. You give me any B, I will give you the coefficients. Right? You give me any B, I will give you the coefficients. That's what I'm saying. Okay. Let me know if that is fine to everyone. Cool. See here. Here I have this, and let's suppose 1, 2, 3, 5, 6, 6, 5, 6, 7, 9, 10, 11. Now, okay, I think this is just a multiplication that I want to show. I don't recall that why. Okay, this was the old slide. Yeah, let's move to the next question. These are the questions. So let's move to this question. Suppose a matrix A contains three linear independent columns. Now, matrix A means which is having five rows. Five rows means everyone is in R5. This is in R5. Everyone is in R5, right? Five rows means R5, right? Okay. R5 में है और चार चार कॉलम्स है मेरे पास, है ना? They have the four columns with me. What can you say about the solutions to Ax equal to B? This is interesting. R5 में चार ही हैं, पांच होते ना तो बात तो बनती, ठीक है, पांच होते तो मजा आ जाता, मतलब R5 में पांच हैं तो फिर क्या ही चाहिए, बट अभी चार हैं, तो अभी क्या बोल सकते हो आप? दिस क्वेश्चन इज बिट इंटरेस्टिंग. लेट मी नो व्हाट डू यू थिंक. Okay, so do not tell me whether there are infinite solution, no solution, these things. Okay, just tell me solution or no solution. Don't tell me number of solution, zero solution, infinite solution. Don't go in this. Okay, just tell me solution exist or solution do not exist. Just tell me this thing. या सो बेसिकली अगर मेरे पास R5 में चार हैं तो मैं ऐसा नहीं कह सकता कि मेरे पास सॉल्यूशन नहीं है. सॉल्यूशन क्या पता हो, इट डिपेंड्स ऑन द वेक्टर्स, राइट? इफ आई विल से नाउ इफ B इज अ लीनियर कॉम्बिनेशन ऑफ कॉलम्स ऑफ A, B इज अ लीनियर कॉम्बिनेशन. एक्चुअली ये तो हमेशा ही ट्रू है, लेकिन पहले केसेस में क्या था कि इफ लगाने की जरूरत नहीं थी, मुझे पता था कि बी तो लीनियर कॉम्बिनेशन होगा ही क्योंकि मेरे पास एनफ वेक्टर्स थे, क्योंकि मैं आई वाज फिलिंग द स्पेस, राइट? बट हियर आई नीड टू जस्ट राइट द इफ बी इज अ लीनियर कॉम्बिनेशन ऑफ कॉलम्स ऑफ ए. अगर ऐसा है, अगर वो लीनियर कॉम्बिनेशन है कॉलम्स ऑफ ए, देन आई विल से दैट आई हैव सॉल्यूशन. अदरवाइज आई विल गिव यू द एग्जांपल, डोंट वरी. फॉर एग्जांपल R5 में हम चार वेक्टर लेते हैं. ओके, चार वेक्टर वो बोले लीनियरली इंडिपेंडेंट ले लो, कोई दिक्कत नहीं, ठीक है. जस्ट टेक फोर वेक्टर्स. लेट्स सपोज 1 2 3 4. Actually, it's not very easy to find linear independent vectors. So there are theorems to find linear independent vectors. मैं कुछ random put कर रहा हूँ, मैं श्योर नहीं हूँ कि वो linear independent बनेंगे, चारों के चारों नहीं बनेंगे, बट assume कि वो हैं, okay, linear independent. Let's suppose 2 4 2 4 6 and then this is 9 3 3. Let's suppose this is 6. Let's suppose this is 9 and then let's suppose this is 10 and then let's suppose this is any random I'm putting. Actually, I don't know whether they're linearly dependent or not, but anyway, so just assume that they are. So I need to actually check whether they are or not, but anyway, let's assume they are. So this is a matrix A, and they have given the four vectors I know which are linearly dependent. That's okay. Now they want to know whether do you have a solution for X equal to B. It depends on the B. Let's suppose B is this. Do you have the solution? Tell me. Yes, you have the solution. What is the solution? Just pick this first one, right? This is 1 2 3 4. I'm just copying it out. Pick this one. You have the solution. This is this one. Actually depends on B. अगर B इसके linear combination में है, currently it is, right? Then you have the solution. Suppose B कोई अलग सा ही है जो कि इसके linear combination में नहीं है, क्योंकि this is not filling the space with these four vectors. I am not guaranteed to fill the space, which means there are vectors which are not in the linear combination of these vectors, right? So maybe there is a B which is not in the linear combination of these vectors. Then I do not have the answer, right? It depends on the B. If B is a linear combination, which means if कुछ भी, let's suppose ये 1 2 3 4 जो कि linear combination में है, right? I mean the coefficients are 1 0 0 0. Then I have the solution. अगर वो linear combination में नहीं है, तो I do not have the solution. Earlier what used to happen? Earlier I used to fill the space, right? R3 में तीन थे, I used to fill the space. तो वो linear combination में होगा ही होगा actually. मतलब फिर मेरे पास choice ही नहीं है. Earlier in this case, I have, so let's suppose in this case, I have three linear independent vectors in R3. It means whatever B you give me, it is always a linear combination of these three vectors. Because these three vectors are actually filling the space, right? तो मैं हमेशा कोफिशिएंट निकाल सकता हूँ. क्यों? क्योंकि B is a linear combination of these three vectors. Now it is basically dependent. I mean B is a linear combination or not. Earlier तो वो होगा ही होगा. Obvious था earlier. Now it may or may not. B may be a linear combination of these columns of A or may not be a linear combination of columns of A, right? On that the solution will depend. So here I will say it depends. If B is a linear combination of columns of A, then I have the solution. Otherwise, I do not have the solution. So that's what I can say, right? Let me know if you have understood this clearly or there is some confusion. Okay. So there might be some vector which is not a linear combination of columns of A. That then you will not be having a solution, right? Cool. Let's go to this question now. What they are saying? Suppose a matrix A contains three linearly independent columns. Okay, A is having 5 cross 2, which means 5 rows and 2 columns. 5 rows means R5 में होंगे सारे कॉलम सारे वेक्टर्स 7 2 3. So 5 rows and 2 columns 3 4 5. So basically I have two vectors in R5 because 5 rows and 3 columns. So this is in R5. This is sorry, contains 3 linear. I think this should be 2. 2 because 3 तो columns ही नहीं है. So I think this should be 2. Yeah, let's just take it 2. And then what I'm saying, I'm asking that what can you say about the solutions to Ax equal to B? What you will say? If these are the two linearly independent, the same story, right? The R5 में मेरे पास दो हैं. अगर 5 होते ना तो मैं गारंटेड बोल सकता था. Like then I can give you the guarantee that whatever B you pick, since I am filling the space, I am the owner of this space. You are giving me 5 linearly independent vectors in R5. Suppose, okay? I don't need anything else. I am the owner. मैं यहाँ का राजा हूँ. अगर आप मुझे 5 linearly independent vectors देते हो तो, if you do not give me 5, then it depends on B. If B is a linear combination of columns of A, then I have the solution. Otherwise, I do not have the solution. Let me just put you one example. Let's suppose that maybe let me just write one example here. Suppose this is the example that I have, where I am saying that these are the two linearly independent vectors in R5. Okay, two linearly independent vectors in R5. Now suppose B is this. Do you have the coefficients for me? Tell me the coefficients. Do you have the solution? Right. Now you can tell me the answer, right? Which is 1 0. Very easy. If B is this. But suppose B कुछ ऐसा है जो कि linear combination में नहीं है. Let me take some B which is not in the linear combination maybe. Suppose here I have the solution. But जरूरी नहीं ना, डिपेंड करेगा solution है कि नहीं है, वो B पे डिपेंड करेगा. Suppose B is this. Okay. In this case I am taking B as this. Now tell me, is there a solution? If you try to check the solution, then you say, okay, I think I should be adding these two, and then I think one should be the answer. 3 6 9 12, but here it is 25, it is 28, so it is misbehaving here. So you will say, okay, 1 is not the answer, and if you find out then it is actually not the linear combination of these two vectors, then you will say no solution. I mean, it depends कि B क्या है, right? अगर अगर आपके पास लिमिट, अगर आप पूरे स्पेस को फिल नहीं कर रहे हो तो वो डिपेंड करेगा बी क्या है. इट्स नॉट लाइक कि सॉल्यूशन ही नहीं है. सॉल्यूशन हो भी सकता है. इन दिस केस देयर इज अ सॉल्यूशन बिकॉज बी सो हैपेंस टू बी अ लीनियर कॉम्बिनेशन ऑफ कॉलम्स ऑफ ए. बी इज नॉट इन लीनियर कॉम्बिनेशन ऑफ कॉलम्स ऑफ ए, then there is no solution, right? Got it? Cool. Let's answer this question and let me know what you are getting. Okay, let me know what you are getting. So they are saying, suppose a matrix A contains 3 linearly independent. So there are 2 rows and 5 columns. Let me know what you are getting here. See, they are saying 2 rows and 5 columns. In 2 rows and 5 columns, can you have 3 linear independent? See, they are saying 2 rows, which means R2 में है. हर कुछ R2 में है. This is in R2, right? This is in R2. Everything is in R2, right? This is in R2. And 5 columns, which is 1, 2, 3, 4, 5. 5 columns. Then can you even have 3 linearly independent vectors here? They are saying that they have 3 linearly independent vectors. It is not even the possibility. Actually, it's not a misprinting. I made the question in such a way that it is not even possible, right? So not even possible. Hope everything is clear till now. Cool. So let's just see that what it is written here. Ax equal to 0 always have one trivial solution which is x equal to 0. Yes, that is true, right? I mean, that's a obvious statement that I have written. कि x equal to 0 को हमेशा एक तो solution होगा ही, which is x equal to 0. At least one solution is already there. Okay. Now let's just answer a couple of more questions, and then we will be seeing some of the gate PYQs based on the similar type, right? I think I have them. Yeah. Okay. So let's just maybe solve this question directly, or do you want me to go step by step? Maybe let's just build some more basics, okay, before I come to this question, because once you have the basics in place, then solving these kind of question will be very straightforward to you. So that's why let's just solve more basic questions, and then I will be coming to the gate PYQs, right? Cool. Tell me whether this is true or false. Consider a matrix A with a dimension m cross n. For a system Ax equal to b, what can you say about the below statement? So what they're saying कि एक matrix है A with the dimension m cross n. Then they're taking a system. System means Ax equal to b. Okay. So Ax equal to b. What can you say about the below statement? Note that b may or may not be 0. If m is less than n, let's suppose कोई भी value लेते हैं 2 and 3, then Ax equal to b always have some solution. What do you think? 2 3 means 2 into 3, 2 rows and 3 columns, right? What do you think? अगर ये हर कोई R2 में है, this is in R2, this is in R2 because 2 rows हैं. Do you always have some solution? Let me know. So I want answers from all of you. There are many people asking, are watching this video, and only 3-4 people are just replying, right? Maybe 5 or 6 people. But others are just silently watching, because if you do not participate, then you will not get to understand many more things. Okay, yeah, amazing. So everyone is saying false. See, you have 3 vectors, that's fine. मतलब 3 वेक्टर है वो ठीक है, लेकिन आउट ऑफ 3 वेक्टर्स अगर 2 लीनियरली इंडिपेंडेंट होते तो हमेशा सॉल्यूशन होता. बट यू डोंट नो कि वो लीनियरली इंडिपेंडेंट है कि नहीं, राइट? आई मीन दिस कुड बी द केस कि तीनों के तीनों एक ही हो, मतलब ये 1 2 1 2, मतलब बस रेप्लिका हो 1 2 1 2 1 2, राइट? यूजलेस है ना ये दोनों 1 2 तो एंड लेट्स सपोज और बी में मैं दे दूं आपको 2 and 3, ये इसका है ही नहीं, राइट? मतलब यू कैन नॉट प्रोड्यूस दिस 2 3 यूजिंग दिस 1 2. So if B is something like this, then you do not have the solution. If B is like this, maybe 2 4, then you have the solution. Basically, जब तक मैं आपको space, you just need to check can you fill the space. If you fill the space, you always have the solution. But आप space ही fill नहीं कर सकते इन 3 वेक्टर से. Are you guaranteed to fill the space? It depends कि 2 linearly independent है कि नहीं है, right? Otherwise I don't know. So if you cannot fill the space, then you do not have guarantee. Always hold the solution. No, you do not have the guarantee if you cannot fill the space. Currently I cannot fill the space. Reason being is that मेरे को 3 वेक्टर दिए गए हैं, लेकिन मेरे को बताया नहीं गया है कि they are linearly independent or dependent, right? I mean 3 of them cannot be obviously linearly independent, but at least 2 of them could be, right, in R2. So that's why I do not know whether independent है कि नहीं. That's why false is the answer, and almost every one of you did it correctly. Amazing. Let's do this question. Don't read this because this is same as earlier, so don't read this. Just read this statement. If m is less than n, then there exists such system Ax equal to b which has the solution. So अब ये क्या बोल रहे हैं कि m less than n, which means let's suppose m is 2 and n is 3, मतलब 2 into 3 का है, then there is a system. System means कि a और b. Okay, system means a और b, मतलब कोई तो एक मैट्रिक्स है a, कोई तो एक वेक्टर है b. there is a matrix A, there is a vector V such that कि आपके पास solution होगा even if B is a non-zero. See, do you always have a solution or not? That's another story. But अभी ये बोल रहे हैं कि कोई तो मैट्रिक्स और कोई तो वेक्टर के लिए सॉल्यूशन होगा. अगर आपके पास ये 3 वेक्टर हैं R2 में, राइट? दिस इज इन R2, एवरीवन इज इन R2, देन कोई तो वेक्टर होगा जिसके लिए सॉल्यूशन हो. हाँ, है ना? मतलब लेट्स सपोज दिस इज 1 2, आई डू नॉट इवन केयर अबाउट अदर थिंग्स. लेट्स सपोज दिस इज 1 2, देन दिस इज 1 0, राइट? 1 0 0. हाँ, ये मैट्रिक्स है, ये वेक्टर है, इसके लिए सॉल्यूशन है. देयर एग्जिस्ट अ सिस्टम. यस, देयर इज अ सिस्टम. दैट्स व्हाट दे आर आस्किंग, राइट? सो दे आर सेइंग देयर एग्जिस्ट अ सिस्टम, देन आंसर इज यस. So just a one request, That's very honest request. If you have actually watched the last session, the session, first session, and you really liked it, then most probably you are in the current session. Then this current number, whatever number of people are watching here, then most probably you have already watched the last session, right? So just put a comment there in the last session. Maybe now only you can put. Okay, whatever you felt like, just put a comment about the session, that whatever you felt like there, because that will just help us to get more recognition. Okay. So that's why this is true, right? I hope you understood that this is true. Let's go to this thing. Consider a matrix A with a dimension m cross n for a system Ax equal to b. What can you say about below statement? Okay, this is the common paragraph. If m is greater than n, if m is greater than n, which means, let's suppose this is 3, this is 2, then none of the systems Ax equal to b has the solution. So they are saying कि 3 रोज हैं, 2 कॉलम्स हैं, किसी भी सिस्टम का सॉल्यूशन नहीं है. कोई भी सिस्टम ए और बी, तुम्हारे पास एक सिस्टम मींस ए और बी एग्जिस्ट ही नहीं कर सकते जिसका सॉल्यूशन हो. ऐसा तो नहीं है. देयर आर मेनी, राइट? सो दिस इज फॉल्स. और लेट मी नो व्हाट डू यू थिंक. Definitely. Let's suppose I just want to copy it. Then there is a solution, right? 1 0 1 0 is a solution if I just copy it. So definitely there are systems. Yeah. Thank you, Indranil. Indranil is saying that CN sessions was very helpful. Yeah. If you attend all the sessions, hopefully all of the sessions will be helpful only. Cool. So let me know if you have any doubt or you have understood everything. Let's just move further. So some of the people have commented. Let me just give them. So some of the people in the session one has commented. So thank you, all of you. It might be very little thing to you, but it means a lot to us, to me, and to Deepak. So that's why I just want to take a moment to thank all of you. So thank you for commenting out. Okay. So now I hope you understood this, that this is going to be a false, right? Let's go to this question. Now tell me whether this is true or false. Let me know. What do you think? This is true or false. Consider a statement. Consider matrix A. So this is the common thing that I have written. Now a statement is saying that for m is less than n, there is a matrix A. M, let's suppose this is 2, n is 3. There is a matrix A which gives solutions of x equal to b for any b. They are saying कि अगर m 2 है, मतलब 2 रोज हैं, 3 कॉलम्स हैं, 1 2 3, oh sorry, 2 rows and 3 columns, right? Which means everything is in R2. This is in R2. Then they are saying कि कोई एक मैट्रिक्स है, there is a matrix A which gives the solution of x equal to b. You give me any b. You give me any b. एक तो मेरी मैट्रिक्स है जो कि हर एक एक्स इक्वल टू बी को सॉल्व कर देगी. आई मीन दैट हैव द सॉल्यूशन फॉर एनी बी. इज दिस ट्रू? लेट मी नो. डू यू रियली हैव सच मैट्रिक्स? Yes, right? I mean, you take a matrix which is, can you give me the most convenient matrix? Can anyone help me with the most easy matrix? Maybe 1 0 and 0 1. And then you put anything here, does not matter. This is a third column. And you give me any b. I will give you the coefficients. Okay. See, you give me this matrix. There is a matrix which is, let's suppose 1 0 0 1. And third column, I do not actually care. I will never use it. So let me just put it dot dot. And then you give me any b. Let's suppose you give me 3 5. I will give you the solution, which is 3 5, and I'm not using the third column, so 0, right? You give me any b, I will give you the coefficients. Okay, cool. Let's just move further. Tell me. So earlier that statement is actually true. Now tell me if this is true or false. If m is greater than n, which means let's take it 3, let's take it 2. There is a matrix A which gives solution for x equal to b for any b. So if we are having 3 rows and 2 columns, 3 rows and 2 columns, which means 1 2 3 rows, which means this is in R3, 2 columns, which means this is in R3, right? Now they are saying there is a matrix A which have the solution for every B. Let me know if that is true. This is false, right? Yeah, this is false. Because you cannot fill the space. So that's why this is false. There is a matrix A which gives a solution for any B. Is this true? अगर 3 cross 3 में 3 cross 3 में do you have a matrix A? Yes, you can have. Can you give me the most convenient matrix? I think you will be giving me this, right? Which have the solution for every B. You will be giving me this. I mean, this is just not the only option. It is just the most convenient option to me, right? Okay. Let's do this question now, and let me know what is the answer that you are getting. I will just from my side, I will not give you any hint because I have told you enough. You are not a kid. Okay. Now you have to solve this question carefully. Let me know the answer. I will just take a pause for 2-3 minutes and I will ask you to solve it. Okay. It is a good question. Just solve it and let me know what is the answer you are getting. Okay. So time is over. Everyone is getting the same answer, which is C. Cool. I have not solved it. And anyone else wants to try? Let me know. So what they are saying? Consider the system each consisting m linear equations in n variables. Okay. So n variables means like whatever the number of variables we have. So each column is basically corresponding to a variable, which means actually it will be very beneficial to us. That's why I'm just telling you one thing. So I think I can just go back. Just a second. Okay. So we have seen representation of it should be here only. Yeah. So as you notice here, so what we will be doing, we will be writing the equations in the matrix format. then you notice here this particular column is for the variable x, this particular column is for the variable y, this particular column is for the variable z. There could be any number of rows. Okay, could be any number of rows, which means I can have just even one equation, I can have two equations, I can have three equations, I can have four equations. So number of equations will tell you number of rows. But the columns, actually all of this, whatever we are going to deal with is just a game of columns. Okay, we are going to focus on the columns only. So number of columns are number of variables. For every column there is a variable, or for every variable there is a column. For every variable x, this is the first column. For y, this is the second column. For z, this is a column. So just mind it that for every variable we have one column. Okay, this is not the variable, and I mean the right hand side is not a variable, so there is no the column dedicated to it. I mean we will be having augmented matrix, but that column is not corresponding to any variable. But yeah, for this every column is basically corresponding to one variable. If there are three variables, there are three columns, right? Okay, might be very obvious, but I just made it more clear. So we are at this question, right? Okay, give me a second. Yeah, we are at this question. Now what they are asking, if m is less than n, right? M linear equation, n variables. N variables means columns. Okay, variable column. Remember, okay, variable means columns. So m into n is the matrix dimension. Cool. If m is less than n, let's just take it 2 and let's just take it 3, which means two rows and three columns. 2 rows, 3 columns. Okay. Then all such systems have a solution. No, linearly dependent independent के बारे में तो कुछ बताना चाहिए था, right? तो ऑल सिस्टम्स हैज अ सॉल्यूशन, आई कैन नॉट गारंटी इट, इट डिपेंड्स वेदर ये तीन वेक्टर्स क्या कर रहे हैं, है ना? इफ m इज ग्रेटर देन n, विच मीन्स अगर ये सिचुएशन उल्टी है, विच मीन्स दिस इज 3 रोज एंड 2 कॉलम्स, देन नन ऑफ द सिस्टम हैज अ सॉल्यूशन. नहीं, ऐसा भी नहीं है, मतलब डिपेंड करेगा लीनियरली डिपेंडेंट है कि नहीं है, राइट? So neither this is true nor this is true. If m is equal to n, then there exists a system. Yes, there exists a system. Can you tell me most convenient matrix? Let's suppose it is 3 into 3. Can you tell me most convenient matrix? I mean, there are many matrices for which the solution exists. Let me just tell you most convenient, right? This is just most convenient. There exists a system. Yes, this is a system. I mean, system means there is a and there is a B, right? You can have any B, which will be having a solution. Okay, so this is true, right? So only C is true. Only third is true. So C should be the answer. Cool. I hope you understood. Now let's just move to one flowchart, which is also very obvious. Now, if they ask you that solutions of Ax equal to B, then I will be just asking one simple thing, that so here m is the number of rows and n is the columns, right? So m is the number of rows, which means that I have 1, 2, 3, 4, 5. Let's suppose 5 rows. So every column is in Rm, right? So every column is in Rm because m is the number of rows, which is important. So I will be asking, do you have, agar मान लो every column is in R3, do you have 3 linearly independent columns? Similarly, I will be asking, do you have m linearly independent columns, right? So this is a very simple question. अगर कोई भी मुझसे पूछता है कि इसका Ax इक्वल टू बी का सॉल्यूशन है कि नहीं है, अगर वो बोलेंगे कि मेरे पास R3 में 3 दे रहा हूं मैं, है ना, 3 लीनियर इंडिपेंडेंट दे रहा हूं R3 में, मैं बोलूंगा कि ऑलवेज हैव अ सॉल्यूशन, कुछ सोचना ही नहीं है भाई, यू आर फिलिंग द स्पेस, राइट? हियर इन दिस केस, इफ यू हैव m linear independent in Rm, right? Every vector is in Rm. If you have n linear independent vector, I will say you are filling the space. Right? अगर वो बोलते हैं कि नहीं, मैं R3 में 2 लीनियर इंडिपेंडेंट देता हूं या फिर एक देता हूं या फिर कुछ भी, राइट? अगर वो बोलते हैं कि मैं 3 से कम दे रहा हूं, तो ऐसा नहीं है कि सॉल्यूशन नहीं होगा, मे और मे नॉट बी सॉल्व, राइट? बिकॉज यू आर नॉट फिलिंग दिस. That's the only difference. I hope you understood. Now I'm having two flowchart. One is this one, which is okay to everyone. Another one is this one. If someone asks me that Ax equal to B का solution है कि नहीं है, if there is a solution to X equal to B or not, then I will be asking that is B a linear combination of columns of A? Okay. बी इज अ लीनियर कॉम्बिनेशन ऑफ, दे से कि हाँ लीनियर कॉम्बिनेशन है, तो मैं बोलूंगा हो दैट्स ग्रेट, है ना। अगर बी लीनियर कॉम्बिनेशन है तो देयर इज ऑलवेज अ सॉल्यूशन, नहीं है तो नेवर अ सॉल्यूशन, राइट। वो डिपेंड करता है ना बी पे। नाउ इट सो हैपेंस कि इस केस में इफ यू आर फिलिंग द स्पेस, ओके, देन बी इज ऑलवेज अ लीनियर कॉम्बिनेशन ऑफ कॉलम्स ऑफ ए, इसलिए ऑलवेज अ सॉल्यूशन। एनीवे मतलब ये दो डिफरेंट, दीज आर द टू डिफरेंट वेज ऑफ लुकिंग एट द सेम थिंग. Even I will tell you 3 4 more different ways of looking at the same thing at ax equal to b. Okay, and I will make sure that you understand everything and you should not get confusion in something. मतलब ये इतनी सारी चीज है ना, like you might think that you know things but you are getting confused. You will not be getting confused. I will tell you in such a way that at the end, if you follow the lecture, at the end you will be crystal clear in all the things. There is, like, it's very simple. अगर ax equal to b मुझसे बोला है, इसका solution है कि नहीं है? There are many ways to look at it. I just told you 2 ways. I will say, is this A filling the space? अगर वो बोल देते हैं कि स्पेस फिल करता है तो टेंशन ही नहीं है, राइट, फिलिंग द स्पेस ग्रेट। या फिर दूसरा तरीका ये भी है उनसे पूछने का, है ना, फिलिंग द स्पेस पूछ सकते हो, है ना, या फिर ये भी पूछ सकते हो, इज दिस बी लीनियर कॉम्बिनेशन ऑफ कॉलम्स ऑफ ए? अगर है, इफ दैट इज द केस, इफ इफ दैट इज द केस, देन ऑलवेज अ सॉल्यूशन। है तो है ही ना, नहीं तो नेवर अ सॉल्यूशन। एक्चुअली ये तो बहुत मस्त तरीका है, I mean, वो तो आंसर ही बता रहे हैं एक्चुअली, लाइक बी इज अ लीनियर कॉम्बिनेशन, मतलब वो बता ही दे रहे हैं कि वो सॉल्यूशन है कि नहीं है, राइट। रोहित इज आस्किंग, सर कैन यू प्लीज टेल मी वेयर टू गेट द पीडीएफ ऑफ दिस लेक्चर? दिस विल बी अवेलेबल आफ्टर 1 hour of this lecture here in the comment section. So I will put a comment and then you can download from the comment section. This will be available in the comment section. Cool. Okay. So this is just a way of looking at this problem. Now, if I just say, let's suppose if I just ask you this thing, that if a linear equation ax equal to b has a unique solution. Okay, this unique thing that I will just cover. Okay, let me just cover a few more things. Then about the unique, I will come to it. So let me come to this unique thing. Now, suppose if I ask a question that b is a linear combination of columns of A, someone says yes. If someone is saying no, तो कभी solution नहीं होगा. If someone is saying yes, तो solution तो होगा. Now I'm being more advanced. I'm asking another question कि वो solution जो है, जो भी तुम solution की बात कर रहे हो, whatever solution you're talking about, now that solution is unique or infinite. Okay, मतलब there is a solution because B is a linear combination of columns of A, है ना, क्योंकि यही मुझे चाहिए, that's the ultimate thing. If B is a linear combination of columns of A, there is a solution. Now let's move one more step further. I will ask whether the solution is unique or the solution is infinite, right? So what do you think? I mean, it depends on what? It depends on the columns of A. So I will be asking a second question: the columns of A are linearly independent or columns of A are linearly dependent? Okay, based on that, I will answer this question. So if columns of A are linearly independent, then I will say that the unique solution, otherwise I will say there is a infinite solution. Okay, so I will just prove it. Don't worry, I will prove it. So we will prove this thing, right? We will prove it. We'll prove next in just 5 minutes. Don't worry about the reasoning. Okay, reasoning I will make it clear. Let's first understand it. Is this flowchart clear to everyone? Ye first part is clear. Okay, if B is a linear combination of columns of A, then great, I have the solution. Then I will be again asking whether the columns are linearly dependent or dependent. Agar columns linearly independent hai, तो I will say कि unique. Otherwise, I will say infinite solution. Isn't it a very good way? In fact, there has been a gate PYQ which is just on the definition. I mean, if you know this flowchart, which means a definition, then you can solve that gate PYQ of 2 marks, which most of the aspirants are not able to solve. I mean, you can solve that question in just literally. I mean, I will not say in the seconds because seconds will you will just take a time to read the question in the second. Literally in 1 minute, that most of the question, most of the aspirants are not even able to solve in 15 minutes. Even in 1 hour, right? They cannot even solve in 1 hour because they do not know the underlying concept. There is a gate PYQ. There are gate PYQs that I will solve just now. But let's first understand things, basic things. Okay. So let me prove it. Which means I will be asking second question. अगर B linear combination है, तो मैं बोलूँगा कि columns of A are linearly dependent or independent. Now you are filling the space or not filling the space is not the concern. लीनियर इंडिपेंडेंट कॉलम का मतलब ये नहीं है कि तुम स्पेस फिल कर रहे हो. R3 में 2 लीनियर इंडिपेंडेंट है. That is also linear independent, right? You are not filling the space, but these are linear independent. So space filling वाला अगर तुम्हारा कोई confusion है, don't bring it here because space filling does not is not a concern here. Okay, we are not dealing with the filling the space. Cool. Now let's just check that why there are infinite solutions or why there is a unique solution. Okay. So what I'm going to do? Okay, let me just prove it. Proof. What I'm going to prove that if B is a linear combination of columns of A, which is given, right? B is a linear combination of columns of A, and columns are linearly independent, then there is a unique solution. That's what I'm going to prove. Let me write it here. If B is a linear combination of columns of A and columns are linearly independent, then unique solution. That's very easy proof. So they have given it, right? B is a linear combination of columns of A. So maybe you can write B as a linear combination of columns of A. But before that, before I prove it, let me know if there is any confusion in the statement itself. Let me know if there is any confusion in the statement itself. Then I will go proving it. Actually, this proof is very easy. Maybe if some of you are Go classes student, then you can just tell me that how we have proved in the class. Otherwise, I am going to prove it. Don't worry. Okay. So should we go proving it? So let's suppose that this B is a linear combination of columns of A, which is let's suppose given to me, right? I mean, it is actually given to me. So suppose that this is given to me that this is a linear combination of columns of A. It is given. Now for the contradiction, I am assuming that there are two solutions. See, what I'm saying here that this B actually to prove it, I should be using the rank and all. Using the rank and all, it is very easy to prove. But for now, I'm not using the rank definition. That's why I will take the another path to prove it. So this is B, this is A, right? This is X. Now they are saying that these columns are linearly independent, right? Columns of A are linearly independent. B is a linear combination of columns of A. That's what also they have said, which means they have given me that B is a linear combination of columns of A, which means B is basically some linear combination, right? Could be anything. This is given to me, which means one of the solution. Can anyone tell me one of the solution? One of the solution is this C1, C2, C3, right? Like that. This is one solution. That's what they have given. Now they are claiming that this is the only solution. See, B is a linear combination. It means there is at least one solution. Let's suppose this solution is C1, C1 to Cn. My claim is that there cannot be any other solution. But for contradiction, let's assume that there is another solution. Okay. I mean, there are two solutions. There should not be basically. This should not be. Do you understand that this is a solution? Are you relating? See, either you write in the vector form x को ऐसे लिखो या फिर ऐसे मतलब उसको इसको लिखो तो solution ही है, right? I hope you understand. So D1, D2, Dn, I am assuming there is another solution. There should not be actually, but for the contradiction I am assuming. What you need to do, just subtract these two equations, right? Just subtract these two equations and then you will understand. So what you need to do, just subtract these two, you will getting 0 equal to C1 minus D1 into B1 plus C2 minus D2 into B2 dot Cn minus Dn You will be getting this. See, you got this. This is just some coefficients. Is this possible? They have said like these columns are linearly independent. B1 to Bn are linearly independent. This is possible only when all are zero. All are zero if they are linearly independent, which means actually C1 equal to D1, C2 equal to D2, which means वो अलग नहीं है, वो same ही है. You do not need to know the proof, but I'm just telling you. Let me know if this proof is making any sense. So what I'm saying here is that you have, let's suppose you have two solutions, right? I have written the two solutions. I am saying if there are two solutions, let's just assume that there is another solution D1, D2, Dn, and then let's just subtract it. Then if you subtract it, then you have to have C1 equal to D1, because C1 minus D1 C plus C2 minus D2, like that. If that is making 0, and if B1 B2 are linearly independent, then these Ci's or whatever the coefficients, this has to be 0, right? This has to be 0, means C1 equal to D1, C2 equal to D2. Okay. Rohit, is this clear to you? Rahil, Mr. Singh, Anamika, Subhadeep, let me know. Indranil. Okay. So I hope that is fine, right? So that's why if you assume there are two solutions, actually they are not. Basically, in simple words, I can say that, let me just put it in simple words. If there is a vector B that you are representing as a linear combination of some vectors, suppose you are representing as a linear combination of some vectors. If that those vectors basically, okay, those vectors are linearly dependent or linearly independent. For this example, if those vectors are linearly independent, then there is only one way to represent B as a linear combination. Okay, then there is only one way. मतलब दो तरीके से बी को नहीं लिख सकते. ऐसे नहीं लिख सकते 2b1 प्लस 3b2 और कोई दूसरे कोएफिशिएंट भी एडजस्ट करते हो, मान लो b1 माइनस कुछ भी, बी आई मीन लेट सपोज कुछ भी, ओके, b1 प्लस लेट सपोज 4b2 और समथिंग. ऐसा नहीं हो सकता. अगर वो b1 b2 लीनियरली इंडिपेंडेंट है, तो एक ही तरीका है बी को रिप्रेजेंट करने का. देन देयर इज ओनली वन वे टू डू इट. यू आर गेटिंग माय पॉइंट? Which means what I'm saying, if B is a linear combination, is a linear combination of some vectors, so in that case, अगर वो vectors linearly independent हैं, तो there is only one way to do it. See, I think I have written it here that if a vector can be represented linear combination of linearly independent vectors, then there is only one way to do it. अगर वो linearly independent के combination से बन रहा है, तो एक ही तरीके से बन सकता है. अगर linearly dependent के combination से बन रहा है, तो there are always multiple ways to do it. Which means that multiple ways means अगर B is a linear combination of let's suppose C1 V1 plus C2 V2 plus C3 V3, अगर B1 B2 B3 linearly dependent है, तो एक तरीका नहीं है इसको रिप्रेजेंट करने का. एक तरीका है तो हजारों हैं. फिर D1 B1 भी है, D2 B2 भी है, फिर तो infinitely many है. You will understand this with the concept of rank little later. But for now, let's just stick with this. Let me know if you are fine with this. Okay. So if you are representing B as a linear combination of some vectors, that's good. Then you will ask, are these vectors linearly dependent? तो फिर B को represent करने का एक तरीका नहीं है, हजारों हैं. अगर वो linearly independent है, तो केवल एक है. Okay. Cool. Now, maybe I can go to this question now. If the linear equation Ax equal to B has a unique solution, okay, then columns of A are linearly independent. So they are saying the solution है और unique है. Unique है, solution है, it means B is a linear combination. Combination of columns of A. Right? अगर solution है तो then they are saying कि unique भी है. Unique भी है मतलब अगर B लीनियर कॉम्बिनेशन है एक कॉलम से, दे आर सेइंग कि एक ही तरीका है इसको रिप्रेजेंट करने का, मस्ट बी लीनियरली इंडिपेंडेंट, राइट? मस्ट बी लीनियरली इंडिपेंडेंट. So this is true. So B is a linear combination of columns of A, and columns must be linearly independent because solution exists. They are saying there is a solution, and then they are saying this is unique solution, which means that column must be linearly independent. Then only there could be unique solution. Okay. This uniqueness and linear independence are related to each other. They are proportional to each other, or you can say implying each other. If there is a unique solution, there must be linear independent, or there linear independent, there will be a unique solution only. So this unique solution exists only when the columns are linearly independent and vice versa. मतलब अगर कॉलम्स linearly independent है और सॉल्यूशन भी है, ओके, तो वो एक ही तरीके से रिप्रेजेंट कर सकते हैं, और एक ही तरीके से कर रहे हैं मतलब वो लीनियर इंडिपेंडेंट ही होंगे, राइट? कूल. ओके, so now are you ready to solve some gate pyqs? So this is a pyq which has been asked in gate 2017, and this is extremely nice pyq, very nice pyq. Let's just solve this pyq. Maybe you can take your time, maybe 2 minutes you can take. It is worth taking 2 minutes time here, and then let me know if you get some answer. Okay, some people have gotten the answer. A or C or C. ठीक है, रोहित is saying A, Anamika C, Mr. What about others? Let me know. What do you people think? Okay, most of you are getting C. Great. Let's just see. It is actually amazing that you are getting C. I think you have not even taken the 1 minute, right? So I'm sure that if your concepts are not clear, it will even take more than 10 minutes, like just to solve using some other methods. If you want to solve, my audio is clear, right? Okay. So what they're saying, there's C1 to Cn are scalars and not all zeros, which means key. And okay, I will connect the dots. Great, this is a good question. Not all zeros, such that this is equal to 0. What does this mean? Where ai's are the column vector an, which means मतलब ai's are basically the columns of a. मतलब इसका मतलब यही है कि a is basically made of the columns of this vectors. I mean a1 to an. मतलब कि a के columns का अगर हम लीनियर कॉम्बिनेशन करें, it is getting 0, and this is having some non-trivial solution, which means there exists some ci. It means that columns of A basically are linearly dependent. है ना? Using this information, they are giving us that columns of A are linearly dependent. Have you understood this statement? They are saying कि equal to 0 में non trivial solution है. इसका मतलब कि AIs are linearly dependent. And AI क्या है? AI is just a columns of A. So columns of A are linearly dependent. Great. I just inferred this from the given information. Then they are saying कि AX equal to B हमें solve करना है, and B is basically a linear combination of columns of A. Great. They are saying that B is a linear combination of columns of A. Then I'm damn sure कि solution तो होगा. अगर C, अगर वो बोलते हैं कि B is a linear combination of columns of A. In fact, they have given the solution. Can you tell me, just by looking at this, can you tell me what is the solution that they have given? Sorry. See, let me just copy. Okay. So suppose they give me this, right? They give me this. Just looking at this, can you tell me what AX equal to B has the solution? They are saying B is A1 plus A2 plus A3 dot 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 an. Can you tell me one of the solution? Yeah, definitely. What is that solution? You will saying some all the questions are one. So this is just one of the solution, right? So they have given one of the solution which is all are one. Cool. So this is given to us that x equal to this. This is one of the solution. Maybe there are many other. They are saying that B is a linear combination of columns of A. Then solution तो है ना? Solution तो one है. Okay. So here they are saying कि यूनिक सोल्यूशन होगा कि नहीं होगा एक बार मैं देखता हूं बट नो सोल्यूशन कैन नॉट बी देयर राइट नो सोल्यूशन कभी नहीं हो सकता फाइनाइटली मैंने कभी नहीं होता आइदर आइदर यूनिक और इनफिनिट सो दैट्स व्हाई डी इज नेवर इवन द आंसर नाउ लेट्स जस्ट लुक एट कि यूनिक सोल्यूशन होगा कि इनफिनिट होगा दैट वन थिंग आई नो कि सोल्यूशन तो है राइट एंड सोल्यूशन इज वन ऑफ द सोल्यूशन इज इवन गिवन व्हिच इज 1 1 1 1 राइट आई मीन दे आर सेइंग कि बी इज अ लीनियर कॉम्बिनेशन वन ऑफ द सोल्यूशन इज गिवन नाउ व्हाट दे आर आस्किंग इज दैट देर आस्किंग कि सॉल्यूशन तो है वो तो पता है एक यूनिक सॉल्यूशन है कि इन्फिनिट है वो हमें फाइंड आउट करना है नाउ सॉल्यूशन है एंड ए के कॉलम्स जो लीनियरली डिपेंडेंट है इट मींस अगर बी को एक तरीके से रिप्रेजेंट किया जा सकता है जो कि a1 प्लस a2 प्लस a3 है दिस इज जस्ट वन ऑफ द वे अगर a1 a2 a3 लीनियरली डिपेंडेंट है देन ये एक तरीका नहीं है फिर हजार तरीके हैं राइट विच मींस देयर आर इन्फिनिटली मेनी सॉल्यूशंस सो दैट्स व्हाई सी इज द करेक्ट आंसर राइट they are saying कि unique solution at x equal to jn where jn is the n dimensional vector of they are saying कि unique solution है और x equal to 1 1 1 1 ही है they are saying कि unique solution है और x equal to 1 1 no x equal to 1 1 1 is a solution but it is not a unique solution there are other solutions also so that's why C is the correct answer let me know if you have understood this right great so this was easy question if you know the concept but if you do not know the concept then this question was very tough let's just move towards solving system of linear equations this is going to be very interesting topic because now you know all the basics now I do not have to put my energy in explaining the basics which means a or x का multiply कैसे करना है it is actually in linear algebra it is 2 into 2 I mean not 2 into 2 but yeah मतलब like linear algebra में there's a basic thing कि a into x कैसे करना है now I told you what is a into x now whatever I'm going to tell you is very basic and very interesting things because now I do not need to tell you the basic now we can go in very good flow okay so now there are two topics which I need to address and every of this topic is going to take 2 hours exact 2 hours because I know how much it is going to take and then whole linear algebra will be finished one of them is this another one is eigenvectors and every of this topic will just take 2 hours because I need some time to finish this because otherwise like you will not be able to answer questions in the interviews or maybe in the gate also right so what do you want can I just finish this topic tomorrow or should you want to finish this topic today let me know or maybe before that we can solve one more question that how many solutions will be there for x equal to b have if b is in the column space means actually this is just a term you do not need to worry about this term column space means that b is a linear combination of columns of a I mean any vector space is basically a linear combination so column space b is in a column space of a means b is a linear combination of columns of a they are saying कि कितने solutions होंगे अगर b is a linear combination of columns of a and columns of a are linearly independent तो कितने solution होंगे b is not in a column space means b is not a linear combination of columns of a b is not a linear combination of column then also they're asking these two things very easy question right you can easily do it let me know yes this is unique this is so Mr. Singh is saying okay he's saying tomorrow Anamika is saying unique Mr. Singh is saying unique Anamika is saying one Rajesh Singh is saying unique and no solution yeah this is unique and no solution correct Rohit is saying unique and no solution very easy question I mean if you know the concept it is easy question otherwise you will be struggling with this a lot so I need to start a new session and like honestly I want to do it today only but I need to just finish up some of the AIMT2 questions. So AIMT2 is still pending for algo subject, I mean algorithms and DX. I've finalized the questions, but need to just finish them, like need to see that whether I should be putting it or should be changing those questions. So we are designing the AIMT2 very 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 carefully. I request all of you to attempt this AIMT2. This is not going to be a hard exam. This is just going to be as per the gate. If you have attempted AIMT1, then I admit, okay, I honestly admit that it was little lengthy AIMT. Reason being is that, I mean, why it was lengthy? Because every question, I mean, it was not lengthy in terms of the question, I mean the number of lines, not in terms of number of lines. It was lengthy in terms of conceptual lengthiness, which means every question needed to have some conceptual clarity, right? In every question you have to put your mind, but it doesn't happen in gate. In gate, like according to my experience, at least 10 to 15 questions are straightforward. Like, do not need to put your even mind, like even if you just solve it for 30 seconds, you should be getting the answer. 10 questions are definitely there, but in AMT1 that pattern was missing, actually, to be honest. So we are designing AMT2 in such a way that you really get the real time gate experience. So that's why I need to spend some time, so that in by 22 it is live. Otherwise, I need to I mean, I need to wake up all the night. That I'm doing for AMT2 already. So I just request. So if we can do it tomorrow. Tomorrow morning, maybe we can schedule 2 plus 2, two classes, or maybe one class. I will be finishing all this linear algebra. I will make sure that you understand everything in linear algebra. This is my guarantee that once you understand all of this lecture, then even if you get 1200 rank in gate, then also you can get into IIT Bombay if they call you for the interview. Otherwise, IIT Madras or Kanpur to definitely will calling you. Okay, and IST might also call you. So even if you are getting 1200 rank, then also you should be getting to these top institutes. That I will try to make sure. Okay, so if you are liking the session, just this is a humble request from me and Deepak. Just put some comments in our videos, so that these videos are getting recognized by some other aspirants. Otherwise, they just ignore the videos. They just see that, okay, there's a few views, there are only 1 2 comments, and maybe these videos are not good enough. So that's how we are getting ignored, and we are continuously putting efforts for 2 years, and still we are getting ignored, and that does not feel good to us also. So that's why I'm just requesting that if you really are liking those sessions, then just put a comment. It's just a 1 second, right? Just put a comment that you have learned everything, and what you felt about the way of explanation. Should there be some feedback that if you want to give, then also you can give in the comment. So just have some interaction in the comment. For every comment, me and Deepak are replying everything, right? So we are looking every comment very closely. So just put a comment, hit a like button, and I hope that will good to us. Thank you, everyone. Thank you. Take care. And just attempt AIM to do. Do not miss AIM to do. Okay. Do not miss AIM to do. Never ever. Do not miss AIM to do.